Students, I am going to discuss a problem of fluid mechanics. The specific topic is Bernoulli's principle. The problem is a tank is filled, water of density 1000 kg per meter cube, oil of density 900 kg per meter cube. The height of water is 1 meter and that of oil is 4 meter. Find the velocity of efflux through a small hole at the bottom of the tank. Okay, so here is a large tank and a small hole at the bottom of the tank. The height of water is 1 meter and that of oil is 4 meter. Okay, now you take a point 1 at the surface of the oil, that is this, and the velocity of its downward direction is v1, and then the velocity of efflux, that is the velocity of water, the emerging through the bottom of the tank, this is v2. Okay, and both the points are exposed to atmosphere, so here the atmosphere pressure and here also the atmosphere pressure. Okay, now you take the reference level for the potential head. Okay, and you write the Bernoulli equation between the point 1 and 2 by using Bernoulli equation. Bernoulli's equation between 1 and 2. We have this pressure head is PA plus the kinetic head is, here it is half rho of oil V1 square plus here the potential or gravitation head in two steps. Here is because of water and here because of oil. So it is rho of water G into height of water plus rho of oil G height of oil. Okay, now on the right hand side this is equals to, here the pressure is PA plus half rho of water as the water is emerging through the hole, so it is density of the water V2 square plus 0, as here the gravitation head is 0. Okay, now as the pressure PA get cancelled out on both sides and V1 is very much smaller than V2 because the velocity of the free surface as it falls is very much smaller than V2. So here it is V1 is very much less than V2. So neglecting this term and substituting this value, we have V2 is equal to 2 rho W G into 1 plus rho of oil to G into 4 divided by rho W. Okay, now after substituting the density of water and oil, this is 1000, this is 9.8 into 1 plus 900 into 9.8 into 4 divided by 1000, and simplifying we have 9.5 meter per second. Okay, now the same problem that can be solved very easily by a shortcut method. So we can have another method. Second method, here first you convert this height of oil in terms of the water. At this interface the pressure exerted by 4 meter height of oil, if it is equal to the pressure exerted by H height of the water, then we can write rho of W GH is equal to rho of oil into G into 4 meter. Okay, now you substitute the value of density of water, G get cancelled out on both sides, H is equal to 900 into 4. So this will give you H is equal to 3.6 meter. Okay, now total height of the water, H is, this is the height in terms of water, so here is 1 meter water and 3.6 meter water. So total height become total height of water above the hole is equal to, basically H is equal to 1 plus 3.6, so it will be 4.6 meter. Okay, so velocity of efflux VE is equal to under root 2GH, so it will be under root 2 9.8 into 4.6 after calculating, this will be 9.5 meter per second. Okay, thanks for watching the video.